assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So the octahedral um, crystal field splitting takes place like this. Two of the orbitals go in a higher energy state than the ground state, and three of them come to a lower energy state. And then the ground state, we call them T2G orbitals, and this as EG orbitals. So for chromium 3 plus, we have for chromium, we know that chromium's electronic configuration is like this: argon and then 3d6 4s1. So for having Cr3 plus, we will have to get rid of this s electron and two of these d electrons, and we will have for Cr3 plus we will have argon and then 3d. Okay, so this one was 3d5, not 6. So 5 minutes 2, that means we'll have 3d3 and no 4s. So we have 3 d orbital electrons here in case of the Cr3 plus. This is how energy is plotted. And then so first we'll have to put the electrons one at a time in each box. So we just put like this, and we don't have any more d electrons left. So this is the octahedral crystal field splitting diagram for Cr3 plus. Then for Cu2 plus, if we find out the electronic configuration of Cu2 plus, we'll see that Cu2 plus has an electronic configuration of argon and then 3d9. So how it will go? So first you have to put one electron at a time, and in that case let's first put them one at a time. And then we have to put the rest of the 4 as opposite spin. So that's how the crystal field splitting diagram for Cu2 plus looks like. Then for Mn3 plus, we need to show low spin or high spin orbital or the crystal field splitting for Mn3 plus. So in case of Mn3 plus, we have an electronic configuration like this, which is argon and then 3d4. So we have 4 d orbital electrons here. So as you know that for low spin orbital splitting, that means that the difference or energy difference between these two is so high that the electrons will first occupy this low energy state orbitals, and when these low energy state orbitals are completely occupied, then they will go to the higher state. So let's put our 4 electrons one at a time, and the fourth one, instead of going to the higher one, it will go just as the opposite spin to the lower energy state orbital, because in case of low spin we know that the energy difference is very high. So that's how the low spin crystal field splitting for Mn3 plus looks like. And then for high spin we know that we have maximum number of unpaired electrons, or this energy difference is not that much high, so electrons can occupy both the low and high low energy state and high energy state orbitals. So let's put our electrons one at a time. So after filling this lower energy state orbital, it will go to the higher one, and we don't have any more electrons or d electrons left. So that's how a high spin crystal field orbital splitting diagram for Mn3 plus looks like. And then for Fe2 plus, we have a formula like this, again argon, and then 3d6. So for this case, we have to find out the low spin orbital splitting. So this is a low spin. So for low spin, as you know that this energy gap is very high, so the electrons will occupy the lower energy level orbitals first, and if there is more electrons after completely occupying these three, then it will go to the higher state. Otherwise it will just only fill up this lower energy state orbitals. So first we put one electron at a time, 1 2 3. We have three more, and since it's a low spin, it will just pair up like this, and that's how the 6 d orbital electrons of the Fe2 plus will occupy the orbitals. And that's how the crystal field splitting diagram for a low spin complex of Fe2 plus looks like.